So we hinted at this yesterday. We are going to take a look at a problem like this today.
Did I give you the right one?
Oh, I didn't hear anything.
So on this picture here, what I want to know is if the density is 21 grams per cubic centimeter, what is the mass of this object? Well, I'm going to give you that this is 32 millimeters high, 54 millimeters deep, and 126 millimeters wide. And I have to give you on our channel that's missing here, I have to tell you that this is 36 millimeters wide and 6 millimeters deep. So this is a problem where we have to basically solve it by subtraction. And there's two ways we can do it. We can find the volume of the whole thing and then subtract out that channel that's missing. Or we can find the area. Remember we talked about cross-sectional area? Volume is an area times the distance. So we could find the area of this end over here. And then multiply by that 54 millimeter depth to get a volume. Either way, it is going to require us to use a standard formula and then subtract a piece from it. But since I'm taking the time to color in this end, obviously we're going to look at finding the area of this end, multiplying by that 54 millimeter depth to get our volume. So the area of that end, we have the area of the rectangle, which is just going to be 126 times what? 32. (4,032) millimeters squared. So from that, then, we have to subtract this segment of a circle here. So we need to figure out the area of that segment. This is where we left off yesterday, was discussing this. So the way we're going to set this up, I'm going to extend this up through here to make a full diameter. This piece is the 6. This piece is going to be how much here? 18. Good. Half of the 36 here. And this will also be 18. And I'm going to call this piece X. So we know from that drawing 18 times 18 equals 6 times X. We do 18 times 18 is 324. So 6 times X. We divide by 6. We get 54 equals X. So X equals 54, which tells us about our drawing here that the diameter is what? 60. Good. 54 plus 6 is 60 millimeters. Therefore, the radius is 30 millimeters. So I've got a 30 millimeter radius. So I'm going to draw that in here. That's 30 and 30. So I'm going to focus now on that triangle a little bit. This is 36 millimeters across here. This is 40, and this is 40. If I cut this down through here, 30, sorry. You're right, 30. Thank you. Little hamster hasn't got on the wheel for the morning yet. So this is then 18 again. And we can find, this is the angle up here that we're actually worried about the whole angle, but we'll find half of it and double it. That angle right there, we're focusing on that angle. 30 is which side of the triangle? Hypotenuse, and the 18 is the opposite. So opposite and hypotenuse means we are dealing with a sine. So I usually write out the formula, then I fill in what I know. And I am looking for the angle. Opposite is 18. Hypotenuse is 30. And so yes, this will be an inverse sine. Theta is the inverse sine of 18 over 30. So 36.87 degrees. Now again, that's this angle here. I really want the full angle here, so I'm going to double that. So times 2 makes it 73.74 degrees. That's the angle that defines our sector. So we're going to find the area of the whole circle now. To find the area of that sector, we start out by finding the area of the whole circle. Pi times radius of 30 squared. (2,826 millimeters squared is the whole circle. Then we find the area of that sector, which is the area of the whole circle, 2,826, times that central angle that we found of 73.74 degrees over 360. So 578.86. That's the area of just this sector. To get the segment, now we got to subtract out this triangle. And the area of that triangle is just going to be 36 is the base times 24 divided by 2. Where did 24 come from? Yeah, if the radius is 30, right, from here all the way out, and this piece is 6, 30 minus 6 means this is 24 here. I also could have done a squared plus b squared equals c squared. 18 squared plus that squared has to equal 30 squared. So 36 times 24 divided by 2 is 432 millimeters squared. We're going to subtract these two. So that gives us 146.86 millimeters squared is the area of that segment here, this piece. Or that's the area of this red piece here that's subtracted out. So that means we take the area of our rectangle here, 4,032. We subtract the 146.86. You get 3,885.14 millimeters squared is the area of that end piece. So then the volume is just that area times the 54. So 3,885.14 millimeters squared times 54 millimeters. Which multiplies up to give us 209,797.56. That's millimeters cubed. That's our volume. You'll notice, however, our density is given as grams per centimeter cubed, not millimeter cubed. So how do I convert this to cubic centimeters? Remember our chart, we have meters, decimeters, centimeters, millimeters. So to get from millimeters to centimeters, it's one spot to the left. But this is cubed, right? So you got to go 3 spots. 1, 2, 3. So it's actually 209.80 centimeters cubed. The 797 I rounded off to 0.80. So we got 209.80 centimeters cubed is our volume in cubic centimeters. And now we can use that and our density, 21 grams per centimeter cubed. Now, you might be looking at this. We haven't done a lot of density calculations. We did a little bit about week 10 or 11 last fall. This 21 grams per centimeter cubed can be thought of as an equivalency. That is saying 21 grams equals 1 centimeter cubed. That's what that's saying. And we can use that as a conversion. So over here, I'm getting rid of centimeters cubed. I'll put centimeters cubed on bottom. And I want to convert to grams. 21 grams, 1 centimeter cubed. So you can see the cubic centimeters cancel out. The only units that will be left will be the grams. So we got that 209.8 times 21 is 4,405.8 grams. On bottom, it's just 1 times 1 is 1, so there's nothing to divide out. So I could leave it that way as grams, or grams to kilograms is 3 spots to the left on the chart, so I just go 3 spots to the left. That's 4.405 kilograms worth of material there. Or about 9.7 pounds. Any questions? I'm going to put another one up here. I'm going to have you guys talk me through it. Tell me where to start. I want to find, let's just find the volume here. We won't worry about finding the density. Okay. So we're going to find this area. So we'll start out with 6 1/4. That's the area of the whole rectangle. 6 1/4 times 3/4. What's that give us? Four and 11/16 inches squared. 4.6875. Then what? Okay. Now you start out by drawing a separate circle. What do I know on this circle? 3/8 is this piece. What's this piece here? How do I get 9/16 there? You got 1 1/8 divided by 2. We get 1 1/8 divided by 2 over 1. So 1 times 8 is 8 plus 1 is 9/8. Divided by 2 over 1 is times 1 over 2, which is 9/16. And then, of course, we are looking for x here. So how do we find x? Perfect. 9/16 times 9/16, which is 81/256, divided by 3/8, which is what, 27/32. Does that work? So x is 27/32. What's that mean for our diameter? Yeah. 27/32 plus 3/8. But I'm going to write 3/8 is 30 seconds. So how many 30 seconds is 3/8? 12. Very good. 8 times 4, so 3 times 4. So that is going to be 39 30 seconds. Or 1 7 30 seconds. Which means the radius is then 39/64 of an inch. So now we're looking at a triangle. This is 39/64. This piece here is the 9/16. The whole thing, remember, is 1 1/8. How do I find that angle? Yes, sine inverse of 9/16 divided by 39/64. So I'm going to have to do some extra parentheses here. So I'll put my 9/16 in parentheses, divided by, and then in parentheses I'll put in my 39/64. At 67.38 degrees. And I'm going to multiply it by 2 to get the whole angle. Is 134.76 degrees. Now, of course, I do need to know this altitude, that height of the triangle. That's going to be the 39/64 minus, remember there was 3/8 here that stuck out. So 39/64 minus 3/8. 3/8 is 24/64. Because 8 times 8 is 64, 3 times 8 is 24. So that makes this height here 15/64 of an inch. Make sense? So our sector, we're going to find the area of the whole circle. That's going to be pi times our radius of 39/64 squared. So 3.14 times 39 divided by 64 squared. 1.166 inches squared. Find the area of our sector is going to be that times our angle, 134.76 or 360. So 0.4365 inches squared is the area of the sector. Then we got to subtract out the area of the triangle, which will be the 15/64 times the 1 1/8. I'll write down as 9/8 divided by 2. Which gives us 0.1318 inches squared. We subtract those two to get the area of that segment. So 0.3047 inches squared. So in the area of that end piece will be the rectangle 4.6875 minus the 0.3047. .3828 inches squared. That's our area. So in the volume, 4.3828 inches squared times 1 3/4 inch depth. That's 1.75 inches. So 4.3828 times 0.75 gives a total volume of 3. I did put in 0.75. 7.6699. So probably 7.67 cubic inches.
Gotta get a hamster some food, man. Eat them.
I've got a worksheet coming at you. In this worksheet, I'm asking the question slightly differently, and I've done that intentionally. I want to see how you react if it's just a little bit different. Yeah, I'll pass that out right now.